My name is Flash Isaac, and I'm a teacher from the future. When I was much younger, I saw thousands and thousands of people fail Jamb and unable to gain admission. This made me travel in time. Now I am back with a Flashlearners Jamb app and a series on YouTube tagged 120 Days to Jamb. My mission is to help you blast Jamb and as well get justice for everyone who Jamb has served breakfast.
Hello, my neighbor. How are you doing? Are you doing okay? This week, Bentley. Next week, Lambo. Now, calculations under induction coil. Now, induction coil and inductor are basically saying the same thing. You have inductors in coil, that is induction coil. And this is an application of electromagnetic induction, as well as transformers, dynamo, heart pacemaker, and some other guys. We've done induction coil and we said a lot of things under induction coil. Our sole aim or our sole purpose or the purpose and the focus of this class is calculations under inductors or induction coil. Jamb generally expects you to know two things when it comes to inductors or induction coil: arrangement of inductors and energy stored in an inductor. Inductors can be arranged in series and in parallel. For series arrangement, you just add the inductors. For parallel arrangement, you multiply over you add. That will be the resolution. Most cases or all the cases, you won't be given more than two inductors to resolve at once. Either you are given one in series with two in parallel, or two in series, another one in parallel. You resolve them two at a time. Now the energy stored in an inductor is half Li squared. So now you are given the inductance and you are given the current, you are able to solve or calculate for energy that is stored. Now look at this. This is an inductor or induction coil. We are asked to find the inductance. Let me see the question precisely. Calculate the total inductance in the diagram below. The units of inductance is Henry. Here we have three inductors. We have 0.5 Henry, we have 0.6 Henry, and we have 0.3 Henry. If you look at here, there is a separation here and a separation here. It goes to show that this guy and this inductor, they are in parallel. Now, we therefore need to resolve this in parallel and solve it in series with this. As such, we've gotten our equivalent inductance. How do we start? For inductors in parallel, the inductance is sum product over sum, and that is 0.6 times 0.3 over 0.6 plus 0.3. That is your equivalent inductance. This will give you 0.2. Now this 0.2 is trying to say that this is 0.5 Henry, and this together, they give you equivalent inductance, and the equivalent inductance is 0.2 Henry, and here is now 0.2 Henry, which is in series with the first one. And to calculate inductance in series, you add them. So L is 0.5 plus 0.2, which will give you 0.7 Henry. That is it. Nothing more and nothing less. If two inductors of inductance 3 Henry and 6 Henry, 3 Henry and 6 Henry, are arranged in series, the total inductance is, so long they are in series, total inductance is adding them up. You are going to get 9 Henry. That is all. Nothing more, nothing less. What if they were in parallel? If they were in parallel, the total inductance would be 3 times 6 over 3 plus 6. Don't forget to know that this is the same thing as 1 over total inductance is equals 1 over L1 plus 1 over L2. So 1 over L total is 1 over 3 plus 1 over 6. So in parallel, it is also like this. But once you simplify this, you are going to get product over sum. 2 inductors of inductance 4 Henry and 8 Henry are arranged in series, and a current of 10 amp is passed through them. I is equals 10 amp. What is the energy stored in them? Energy stored in inductor is half Li squared. That is half times. The inductors are in series, so inductance will be 8 plus 4, that is 12, times current is 10 squared. That is basically it. And the energy is in joules. If we are told that the inductors are arranged in parallel, you resolve these two in parallel, that will be your value here instead of 12. And parallel will give you a lower value of the inductance. And this question I'm looking at here says the total energy stored in an inductor of inductance 5 millihenry when a current of 6 amp flows is dash. We are given the inductance L to be 5 millihenry, and we are given current to be 6 amp. In this case, we don't have 2 inductors, we have just one, like the equivalent inductance. This is the inductance, not the inductor. It is in millihenry. We need to convert to Henry because it is more appropriate for us to solve in Henry. To convert from millihenry to Henry, it is 5 times 10 to the power of minus 3, because milli is times 10 to the power of minus 3. If this is true, the energy stored is therefore 1 over 2 times inductance 5 times 10 to the power of minus 3 times current 6 squared. That is basically it. There is nothing difficult under inductors, induction coil, and energy stored in inductor. And I do hope you found this interesting. Subscribe to this channel. Tell others about the Flashlearners YouTube channel. And I hope to see you in the next episode. Take care of yourself.